In this video, we're going to look at an application that should result in a quadratic equation. Let's take a look. Sam has 132 linear feet of fencing with which to make movable pens as shown in the figure. Find the largest possible fenced area. All right, so what we're trying to determine is the largest area. So I think the first thing we should probably do is try to write an equation for area. Equation for the area of this pen. So let's take a look at what we've got over here. We've got these really two pens, like as a footprint. I could do something like this. That's split up into two different pens, and then this whole distance is L. And this is W, and this is W, and this is W. So, I mean, the area of this big rectangle right here, the area of this big rectangle is length times width. That's the area of this pen. Okay, now the thing we haven't really taken into consideration yet is the fact that we're using 132 feet of fencing. So let's also think about writing an equation for the fencing, which in this case is sort of like the perimeter for the fencing. So we've got 132 feet of fencing, 132 feet, and we're going to use that fencing. We're going to use it, we're going to put here, 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 and here for that fencing. Okay, so let's see, we need W 3 times, right? We need 3 lengths of this W. And then we need to put some fencing here and here. So we need 2 lengths of this L, whatever that L is. And add those together, and that's going to add up to be our 132 feet of fencing. I'm just going to take the feet out here for now. All right. So we really have sort of like 2 equations that involve length and width. Now what we really want to do is maximize this area. So we want to find a formula for area, but we only want one variable over here. We don't want length and width. So what we can do is we can use this equation and we can solve it for either length or width and then substitute into the other equation. So I don't care which one we solve for. Let's solve for length. All right, so I'm going to subtract the 3W over. Let's write that out. Minus 3W from both sides. So those are not like terms. I can't combine them. I just write 132 minus 3W equals 2L. And then to get L by itself, I'm going to divide both sides by 2. Now, you could leave this as a big old fraction like that. Or you could divide each term, like 132 over 2 minus 3W over 2, which we could write as, what is that, 66 and a half, 66.5 minus 1.5W. That's kind of nice because then you don't have the fractions, but either way, you could use the fractions or the decimals. Okay, actually, right, this is just 66. I don't know what I was thinking there. That's an even number. That'll go in nice. 66. That's even better. So now what we can do is we can take this 66 minus 1.5W, which is length, and we could plug it in here for the length. So my area is my length, which is 66 minus 1.5W times W. Now we just have 2 variables over here, width and area. So the area is now dependent upon the width. And I'm just going to distribute that W in there to write this as a quadratic. So I think it would be pretty cool right now to just actually take a second and go plug this into Desmos and then think about what it's telling us. So let's go do that. All right, so here I am in Desmos. I've put my equation in and I get this shape. Because Desmos is just defaulting to like it's 10 by 10 kind of thing. But obviously this goes way up here, so I need to adjust my scale. So I'm gonna move my cursor close to the x-axis and I'm gonna hit shift. Notice how that changes my cursor. And I'm gonna pull this down until I can see what's going on. And then I'm gonna move my cursor to the y-axis or the x-axis and pull this over so I can see what's happening. I'm gonna let go of my cursor and sort of center this. There we go. Okay, this I can see what's happening now. So this is the width down here on the x-axis, and this is the area. So I can see if I make that W value like 8, close to 8, then I can get an area of 432. But if I make that width bigger, like 14, I can get an area of 630. That's even more area, right? So I continue to increase my area up to... If I make the width 22, I can get an area of 726, which seems to be the biggest possible area. If I continue to increase my width, my area starts to decrease again. All right, if I make my width 0, I'm going to get an area of 0. If I make my width 44, I'm going to get an area of 0. Let's see why that would be. If I make my width 44, 44 times 3 is 132. So I won't have anything left for my length, and I'll just have basically like I've squished with no area like that. All right, so we're expecting our answer. Desmos tells us that our answer is 22. A width of 22 will maximize the area of 726. But let's say we were doing this on a test and we didn't have Desmos. What is the important point here on this parabola that tells us our maximum? Yeah, it's the vertex, okay? The vertex is going to tell you the maximum area. So if I don't have access to Desmos, I just need to realize that I need to find my vertex. Now, what about this problem tells me I need to find my vertex? Largest, all right? Largest, maximum. Trying to find the maximum area. So that screams vertex. So the W value of the vertex is going to be negative B over 2A. That's a nice little formula that you need to memorize. My B value is 66. Don't get tricked here. The B value is not always the second number. It's what is the coefficient on the term that's to the first power. So in this case, because I don't have it written in descending order, my B value is showing up first. My A value is negative 1.5. So I have negative opposite of 66 over 2 times negative 1.5. That's going to end up being a positive value. Let's see, 66 divided by 2 times 1.5 is 3, which is 22, which is what we expected from our graph. So that's actually not the largest area. To find the largest area now, we need to find the A value of our vertex by plugging in 22 into our equation, either equation here. So 66 times 22 minus 1.5 times 22 squared. And if you multiply that out on your calculator, you should get 726. So our maximum area is 726 square feet. All right, I hope that helps.